Hello, everybody. We are live. We are starting now with our very first video.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
Hello, everybody. Welcome. Mitakuye Oyasen. This is Annette Lee speaking to you from Minnesota Makoche, the land where the water reflects the sky, the original territory of the Dakota and later Ojibwe people. I am mixed race Lakota. My communities are Ojibwe and Dakota Lakota. I am speaking to you today with a good heart, and we have put together this incredible programming, Two-Eyed Seeing, African Indigenous Astronomy, and NASA Moon to Mars. Before we get started, I just want to take a moment, a breath, to acknowledge that we are all going through a really hard time with COVID and the COVID hardship and suffering and loss that it has brought. I want to acknowledge all those that have died and their families, all those that are sick and their families. We come here today, we have put together a really great program called Two-Eyed Seeing. This teaching has been given to me from my friend and colleague, Carola Knockwood, who is Mi'kmaq. And this is, has been taught to her by her elders, Etowaptamunk. It means to see with the best in one eye with indigenous knowledge, and to see with the best we can in other eye with the Western science, but to see with both eyes for the benefit of all. And that's what we're trying to do here. So I want to acknowledge that we have many ways of seeing. The other acknowledgement that's important is giving thanks to our funders and supporters, NASA, Next Gen STEM. Okay, with that, we're going to pass it to Miss Osuji, and she has a land acknowledgement to share.
Chukwu abịama, ekekere ụwa, ekele m elu na ala, ndewonu, ala nna dịrịkwa, ndị iche, ekele m unu, cha 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 Igbo kwenu, kwezuonu. Greetings, creator of the world. Greetings, heaven and earth. Greetings, our ancestors. Long live our land. Our umbilical cords are buried in the land to continue our linkage to Allah and Ndiche. We have a duty to sustain the land and leave it clean, healthy, and just for posterity.
Okay, Pelamia, thank you, Dr. Osuji. And with that, I'd like to pass the torch to our main host, which is Dr. Jarita Holbrook. Take it away, Jarita.
Good afternoon, good morning, everyone. I'm Jarita Holbrook of Native Skywatchers Two-Eyed Seeing. Welcome to African Indigenous Astronomy and NASA Moon to Mars. We have a great event planned today featuring NASA scientists, secondary school teachers, Dr. Osuji, who you've already heard from, teacher Said, and teacher Vanegas, the students of Washburn High School, and the students of All Nations South High School, both in Minneapolis, Minnesota. And I mustn't forget artist Jasmina and our project lead Annette S. Lee, who you've already heard from. So we're going to start with a welcome poll. The question is, take your time to answer this. Where are you right now as you tune into this program? North America, Central America, South America, the Caribbean, Europe, the Middle East, Asia, Pacific Islands, Australia, New Zealand, Tasmania, or Africa. So I'll give you about 15 more seconds to answer the poll. All right, I'm going to go ahead and end the poll. So most of our team are in North America, and we'd like to welcome everybody to this unique online event. I want to make people aware of the question and answer function at the bottom of the screen. We do not have a chat, so please do not use the question and answers button as a chat function. It's really for asking questions to us panelists. Okay, looks like everyone has stopped voting, so I'll go ahead and end the poll. And overwhelmingly, people are in North America. 117 people are in North America. But we do have representation from everywhere except for the Middle East and from Australia, New Zealand, and Tasmania. So welcome everybody to this wonderful event, African Indigenous Astronomy and NASA Moon to Mars. Next, it's my pleasure to introduce NASA scientist Alphonse Sterling, who's going to give us an overview of the Apollo program. And Dr. Sterling is with us, and he will be answering one question. So go ahead and put your questions in the poll.
Hello, everyone. My name is Alphonse Sterling. I am an astrophysicist at NASA's Marshall Space Flight Center in Huntsville, Alabama. And I actually specialize in studying the sun. But today I want to talk with you about the early days of the American space program, in particular the Apollo program. So, as you must already know, Apollo was the set of space missions that actually took us to the moon in July of 1969. That was on Apollo 11. But with this was all very important to me because I grew up watching these space missions, and they were a big influence on me, and in fact that's part of the reason why I'm here today doing what I'm doing now. So anyway, I want to tell you a little bit about that. Now, Apollo carried 3 astronauts, and we didn't just start off with launching 3 astronauts into space, but we did things in a progressive, stepwise fashion. So first, the space program sent 1 person into space. That was with the Mercury program, and that was over 1961 to 1963. And then next there was the Gemini program, and that launched 2 astronauts on a spacecraft, and that was over 1964 until 1966. And all of those space flights were in Earth orbit or in the Earth and near the Earth environment. They didn't go to the moon yet. So it wasn't until Apollo. Now, to explain Apollo, first let me jump to Apollo 11, the first one that landed humans on the moon. As I said, that was in July of 1969. And the way the mission went was, first the astronauts were launched, and then they went into orbit around the Earth. They orbited the Earth for about 2 times, And then they launched on a trajectory. They fired their engines again, and they moved on a trajectory heading toward the moon. And it took them about 3 days to get to the moon. And then they orbited the moon. And then Apollo actually, the spacecraft had two main parts. One was the command service module, and that contained the astronauts when they were launched. The three of them were in the command module. But they also connected to a second vehicle that they took with them called the lunar module. And that's the one that actually went to the moon. So the command service module had to hook up with the lunar module, and that's the way it went into orbit around the moon. So they did that, and then initially all three astronauts were in the command module, but two of them would transfer over into the lunar module, and then they would descend and go to the moon, while the one astronaut remained in the command module circling the moon all this time. So the two astronauts landed on the moon in the lunar module, and they did their work there, and then the upper half of the lunar module would launch, and it would come back and meet the command module again, and the two astronauts who went to the moon, along with the moon rocks, would transfer back into the command module, and then that would leave the moon's orbit, head back to the Earth, and then they would land by splashing down in the ocean. So that was Apollo 11. But again, it was a very methodical progression from the earliest Apollo missions until Apollo 11 and then onward. So the earlier Apollo missions were aimed at testing the various systems. So Apollo, we'll start with Apollo 7. Apollo 7 first just tested the command module, so it went into orbit around the Earth. And then Apollo 8 was actually very important. That launched in December of 1968, and it took 3 astronauts into orbit around the moon. So that was the first time that astronauts from any country actually had ever left Earth orbit. And they went into orbit around the moon. They didn't land. They didn't even have a lunar lander. But that was the first time that we could actually see the moon that close. And it was also the first time that we could even see the Earth rising above an alien body. Now, we've all seen the sunrise and the moonrise, but they were actually able to see the Earth rising above the lunar horizon. And you will see, and you will read in your history books, that 1968 was actually a very troublesome year on Earth, both in the United States and actually all over the world. And so I think it really affected a lot of people to see how small and fragile the Earth looked rising above the lunar surface that way. So that was a very important mission. Then Apollos 9 and 10 tested the lunar lander, in first Apollo 9 only in Earth orbit, and Apollo 10 in orbit around the moon. And then Apollo 11 finally landed on the moon. And then Apollos 12 through 17 were all planning to go to the moon, and all of them, except for 13, did. And they went to different parts of the moon from Apollo 11, and then they saw different types of rock formations and different types of structures. So with all of those missions, we could put a nice, good picture about the history and the geology of the moon together. Now, Apollo 13, of course, you may see again in history books, and also there's a movie about it, because they had trouble going to the moon, and they almost didn't make it. But it's really quite a story of perseverance that they actually managed to get back alive from that mission. So that was big feat by the astronauts and by the people on the ground working to get them back. And I jumped at the beginning to Apollo 7, but actually Apollo 1 was a test on the ground of an Apollo mission, and that was in early 1967. And that one actually did not work very well. And in fact, they had a fire on that Apollo mission in that spacecraft, and they ended up losing all 3 astronauts. So they actually gave their lives to try and make progress. But as a result of that, we did learn a lot, and we learned how to improve the capsule and make it much safer. And eventually it led to going to the moon with Apollo 11 and the subsequent missions after that.
Thank you so much, Dr. Sterling. So our first question that came through is, depending on the age of the audience member, they don't know what a trajectory is or an orbit. So it's very basic, but could you take a minute to explain those?
Sure, yes. Okay, hello everyone. It's great. Sounds like a great program you're putting together. Thank you, everyone. So yeah, trajectory, I mean the path that the spacecraft follows. So now orbit, so the Earth is, of course, in space. And when you have something going around the Earth, and trying to think of the scientific principles needed, but you have it going with a particular speed, then it'll actually be able to keep on going for really forever without applying any energy to it at all. So a way to think of it is taking a ball and putting it on a string and spinning it around your head, just spinning it around. When you do that, the ball keeps on going. And of course, if you let it go, to run away. Well, that's kind of what satellites do when they're in orbit around the Earth. They're going around. And in that case, by them actually having the velocity to keep in motion, that is what is actually trying to push them away from the Earth. But what's holding them back from going away is gravity. So what you have to do is you have to balance the speed that you're going around with the pull of gravity. And that's how you keep something in orbit. So orbit is just something that is going around the Earth or some other body in space, and it just keeps on doing it. So the Earth orbits the sun, actually. It takes 1 year to go around the sun. So that's the length of it. So you could say that the trajectory of the Earth is nearly a circle going around the sun when it's in orbit around the sun.
Great, thank you so much, Dr. Sterling. And I hope you'll be able to stay on to answer more questions at the end.
Sounds good, thank you.
Right, so you've heard about Apollo and you've seen a video about Artemis. Now we'd like to go to teacher Vanegas' class, who's going to tell us more about those two, Artemis and Apollo.
Apollo is a Greek god who drove the sun chariot. He is the twin brother of Artemis. He is the god of poetry, sun, music, and healing.
About Artemis. Artemis is a Greek moon goddess. She is the twin of Apollo. She is the goddess of hunting, the wilderness, wild animals, and the moon.
A story, Apollo, Artemis, and Orion. Artemis was in love with Orion. Her brother Apollo was upset because she was neglecting her hunting duties. Apollo decided to trick Artemis. He told Artemis to shoot a hare that was in the distance, but really he knew it was Orion. Artemis accidentally shot and killed Orion. Artemis put Orion in the sky as a constellation so she could always remember him.
Great. Now it's my pleasure to introduce our next NASA scientist, Dawn Stanley, who's going to tell us a bit about the Artemis project.
Hello, I'm Dawn Stanley. I'm a manager within the Exploration Systems Development Division within the Human Exploration Mission Directorate at NASA headquarters. And today I'm going to talk to you about our Artemis program. Artemis is the first step in the next era of exploration for humans. NASA is partnering with national and international partners to develop and establish a sustainable presence on the moon as we develop technologies to take us to Mars. And so NASA is so excited to be developing technologies that's going to take the first woman and the next man to the moon in 2024. And so how are we going to do that? Well, NASA, we're developing the most powerful rocket ever built, the Space Launch System, at Huntsville, Alabama at the Marshall Space Flight Center. This rocket is evolvable in order to meet the different missions determined by our administration. In Houston, Texas, at Johnson Space Center, we are developing the Orion crew capsule, which will, of course, house our astronauts. And then within the ground systems at Kennedy Space Center in Florida, our ground systems that will stack and integrate and test our integrated rocket are being developed as we speak. And then for our future missions, we are partnering with the Gateway program and the Human Lander System as we develop lander lunar systems for the moon and beyond. And so we're so excited. They also have international partners. Through the Artemis Accords, we're developing a practical sense of guidelines and principles that will guide how we interact in the 21st century in space with other countries. And some of those countries that are a part of this accord include Brazil, Japan, Australia, the United Kingdom, and of course the United States of America. And we are also partnering at NASA with the European Space Agency as a part of our component development for our Orion crew capsule. So what are we doing to get there? Well, we have 3 missions that we're working on right now. One is the Artemis 1 mission, in which we will launch later this calendar year. And this will take a non-crewed Orion capsule to a distant retrograde orbit around the moon. And we will go 40,000 miles beyond the moon, which is 280,000 miles from Earth. And then, of course, bring the capsule back home. And then for Artemis 2, we will take crew, and we're excited about that, to a lunar orbit as well, and exercise our systems. And then this is in preparation for Artemis 3, which is in 2024, which we will, of course, land the first woman and the next man on the moon. And this particular mission, we are so excited to be able to take astronauts back to the lunar surface and explore more parts of the moon than we ever have before. And so this is what our Artemis program is for our first 3 missions. We are excited that you want to know more about Artemis and NASA. And if you'd like to know more information, we invite you to go to www.nasa.gov and then search for Artemis program. And then we also have Twitter and Facebook feeds as well. So we look forward to seeing you out there, and we look forward to going to the moon, the Mars, and beyond. Thank you.
Big thank you to Dawn Stanley. Now, let's go to Africa. Here's our next poll. And the question is, how many countries are in Africa? The options are 1 country, 5 countries, 26 countries, 43 countries, or more than 50 countries. Wow, this is exciting. I get to watch as you guys are voting. Okay. I'll go ahead and end the poll. Now, before I share the results, I want to, well, actually, I'll go ahead and share the results. So the answer is, of course, more than 50 countries are in Africa. In fact, there's 54, depending on how you count. So let's do a flyover of Africa so that you can see how big it is. So that was a flight from north to south, and now going back up to the north and over to West Africa, past the Sahara Desert, and down into Central Africa, and now we're facing south. We're spinning around and facing south, putting South Africa and that was our flyover. So you got an impression, I hope that was pretty quick, of just how big Africa is. 54 countries. Most people think Africa is just one country. I've given talks all over the world, and I remember going to India to give a talk, and people would ask me, what's going on in Africa? And I'd answer, which country? Because there's 54. So now we heard about Apollo and Artemis, but there's actually twin gods of the sun and moon in Africa as well. And they are found in Benin. So let's listen to artist Jasmina as she talks about her artistic works on those two gods.
Hi, I'm Jasmina, and I've been gifted this honor of being the artist of these two beautiful gods and goddess, Mawu and Liza. So Mawu is the goddess of the moon, and Liza is the god of the sun. Like Apollo and Artemis, Mawu and Liza are twins. My inspiration for these two pieces, the Benin bronze art sculptures that show these beautiful people of the kingdom of Benin. Mawu's dress or top piece thing. I was looking at fabrics in Benin, but actually the fabrics are originally from Ghana.
Hello, everyone. Here I am with our artist, Jasmina. Does anyone have a question? Just one question for Jasmina. Let's see. So they're going to put the questions right here.
Okay, cool. Hi,
everybody. Here we are.
Mm-hmm.
Oh, from Isabel Hawkins, who was a NASA scientist. Good to see you online today, Isabel. Do the twins have gender fluidity? I'm not sure if you could answer that question, but I know the answer, that Mawu and Liza not only are the sun and moon god for the Fon people, but in West Africa, they have different roles. So sometimes Mawu represents both the sun and the moon, and there you have some gender fluidity, and sometimes not. So depending on the ethnic group in West Africa that we're talking about, there will be or there won't be gender fluidity. So thank you so much for our question. And I want to continue on to, now you made me lose my train of thought, because that was supposed to be Jasmina's question.
Yeah.
Okay, so it's my pleasure to introduce teacher Amun Saeed, who will be sharing some of her sky wisdom.
Good morning, everyone. My name is Amun Saeed. Thank you for introducing me. So my story, I am of Somali descent, and I do have elders that do know knowledge about being in the nomadic regions and also surviving them. So my great-grandfather used to use his hands to measure the distance of the lightning and the amount of water that the land would get based on just oral knowledge passed down in the family. This knowledge was used to predict droughts, storms, and rain. Now, listening to the stories from my grandmother, who was the one that took this knowledge from him, she would tell us at night how the moon in that area meant us, and how the stars meant more than just the constellations that we see in the sky. One of the big ones that I learned about was one of the sky camel, which we will talk about in a little bit. So I'll give you a little background on Somalia and Somali, the language. So Somali, one of the Kushite groups of the Hamaro-Semitic or Urithric languages, is unlikely to be younger than Arabic, and probably evolved its own distinctive characters at about the same time as Arabic, if not indeed earlier. Now, since it primarily was spoken as an oral language before the actual contextualization and written form of it was invented, it has been an oral literature which has existed in this region from the earliest time in which the language was spoken by the pastoral nomads. Their lives and well-being were then, as now, very closely bound with the rains and the prediction of rain and the necessary calculations of the seasons. Riddles and songs were an essential feature. One of the key components here is that a lot of the stuff, a lot of the knowledge, a lot of the oral tradition is based on songs and riddles and folk tales in which lessons were learned and knowledge was taken from. So one of the big ones that we hear about is about the Aurka, which is the sky camel. Now the sky camel is a black image in the sky at night in the region of Wadamahoro or Wadamaluduk, which is the Southern Cross. There are two regions that cross each other, caused by the fact that there are no important stars in the area, and in the blackness it is said to appear the shape of a huge male camel on dark nights in the months of April and May. Somali folklore has a legend about the sky camel. It says that camel was once, long ago, positioned in the north above the mountains of Shida and in the Warsangele district of Irigavo. One year there was a severe drought, and the people of the district attacked the great sky camel and tried to kill it from meat. First, they built a huge platform on top of the highest mountain of the Eshida, tall enough for the people standing on it to reach up to the tail of the sky camel and cut it off. Now, the camel felt the pain and raced off to the south, where it is still to be seen. The Milky Way is said to be the path taken by the sky camel on its hurried journey southwards. And if you look at this picture right here, you'll actually see that the camel is facing upwards. And that is the cross in the Milky Way that we see when we look up. If you look at the shape right here, you'll see that there is two humps on top of what looks like a mouth. In front of just a sky full of light, there's just a certain dark area that has a shape. And this is what a camel looks like in comparison to the picture. So if we go back and look at the camel, you can see its hump is right there and its face is pointing upwards. And if you look at an actual camel, there are similarities in how the neck and the humps are shaped. In the month before the start of the Guren, the sky camel is seen with its head down towards the east. It is said to be drinking water, which means in April, which means he's drinking from the water right there. In April and May, its image is upright again and can be seen clearly between 8 and 12 o'clock at night. Apparently satisfied and chewing the earth heartily, the earth is grass. In June and July, its head appears to be turned upwards, which is similar to the picture, towards the zenith, its back falling towards the west, apparently cropping the tops of the tree. In fact, the three different periods of the grazing year in the region of Africa are closely pictured by the onset of the blue rains. All the livestock are busy drinking the spring waters. Towards the middle of the rain, when there's plenty of green grass and water, the animals have fed so well that they spend long periods contentedly chewing and sitting. When the rains are finished and the green grass parts, the camels begin cropping for the trees. And if you look at an image taken from Google, you'll see that it is actually the same shape I was showing before. And it is outlined in this picture. You can see the two humps right here. And if you look at a camel in a dark shade, it looks similar. Whereas the neck is here, the hump is here, and the other hump is right here. You can see the two distinct humps. So in this dark region of the sky, whereas we look for constellations, when we look at constellations, we look at certain stars that map together. In this region of the sky, people just look at the dark part of the sky and take it as a shape that signifies certain weather conditions and weather times. Thank you so much.
So we had the opportunity to join Raja Gohathakurta, who is a professor at University of California, Santa Cruz, while he was observing at a telescope. Let's see that. Rita and
Jasmina.
Okay, Emily?
Hi, I'm Emily Cunningham. I'm a Flatiron Research Fellow. Excuse me. I'm a Flatiron Research Fellow at the Center for Computational Astrophysics at the Flatiron Institute in New York City.
Thank you. Raja?
I'm Raja Gohathakurta. I'm a professor of astronomy and astrophysics at the University of California, Santa Cruz.
Okay.
Yes. Hi, I'm Yusing Fun. I'm a third-year PhD student at UC Santa Cruz in astrophysics department, and my advisor is Raja.
I'm in California. I'm at home in California, in Los Altos, California. Yuting is in Santa Cruz. Emily, you're in Brooklyn?
I'm in Brooklyn.
And the telescope, though, is far away from each of the three of us. Eric is in at the Center for Astrophysics at Harvard. He's in Cambridge. He's at home in Cambridge. And the telescope is on Mauna Kea, on the sacred mountain of Mauna Kea in Hawaii, on the big island of Hawaii.
Okay, so Milky Way is this disk, and it's embedded in this huge dark matter halo. So the way that I actually think about it is like the Milky Way disk is a teeny tiny hamburger in an enormous hamburger bun. And what we think is there's this massive satellite, this dwarf galaxy that's smaller than the Milky Way, but that's still quite large, that's falling into the Milky Way. The Milky Way is going to eventually disrupt this small galaxy and absorb it into its own galaxy, into its own dark matter halo. But the problem is usually this can happen without really perturbing the Milky Way. The Milky Way is just gobbling the little galaxies and doesn't care that much about the little galaxies while it's doing it. But because the Large Magellanic Cloud is this massive galaxy, it's really disturbing the Milky Way as it's falling into its dark matter halo. And so this is going to shift the Milky Way within its little hamburger bun. It's not going to be at the center of the hamburger bun anymore. And so if we look at really distant stars, we can try and figure out if the Milky Way, if this prediction is correct, if the Milky Way is actually centered in its hamburger bun. Was that better?
That was so awesome.
Okay. Okay, good.
That's great.
Okay.
In the southern hemisphere, the Large Magellanic Cloud and the Small Magellanic Cloud are visible naked eye. And just outside of cities, you can see the Large Magellanic Cloud, or in dark spots in the city as well. You can see it. And traditionally, the San people and the Khoisan people thought of it as little patches of grass where animals in the sky would go to graze. So that was the Large and Small Magellanic Cloud. In the southern hemisphere, especially in South Africa, it's really easy to see the Milky Way. It's big and it's really bright and it dominates the night sky. Among the San people or the Khoisan people, there's a story of how the Milky Way was made by a young girl. This young girl had just reached womanhood, and she was in seclusion because as soon as you become a woman, you have these magical powers that are hard to control. So they isolate them among the San women. And it's several days of isolation, and she had so much roots and vegetables to eat. But they were running out, and she was becoming hangry, both hungry and angry. She was hangry. So she went out from seclusion, and she found that all the men were gone hunting and that they had been missing for several days. That's why there was no meat. And she got angrier, and they assumed that the men were lost, so they couldn't find their way home. They traveled too far. So the young girl picked up the bonfire, the fire, and she threw it up into the air. And that's what made the Milky Way. So the white parts of the Milky Way are ashes from the fire, and the glowing parts, the stars of the Milky Way, are the little embers from the fire that were glowing. And the dark spots are the pieces of wood that hadn't burned yet, like the charcoal that were in the fire. So all of that made a big beacon in the sky so that the hunters could then find their way home, bring the meat, and let her eat. So that's probably the most famous legend of how the Milky Way came to be. But there's other legends from the Sotho people, which are sort of North South Africa, and they say that it's that the stars in the Milky Way are so numerous that it's like watching a herd of uncountable elephants. So they say it's the path of the elephants. So those are just two legends about the Milky Way from Africa. All right, so
that is awesome. That is so cool.
What he's doing is he's lining up this next star, which is a very bright RLR. He's lining it up on the slate. You can sort of see that happening.
Wow, that's really bright.
It's really bright. Okay, and we're going to do 2 5-minute exposures. So thank you, Jarita. Thank you, Jasmina, for joining this Zoom call and speaking with us about our science.
Yeah, thank you so much.
Okay.
Thank you.
Have a good observing last hour.
Bye.
Thank you.
Take care. Thank you so much.
Thank you.
Bye.
Bye.
Okay, so now from that, we have another poll, which is which galaxies can you see without the aid of a telescope? So you can see them with just your eyes. And here are your options: the Milky Way galaxy, the Large Magellanic Cloud, the Small Magellanic Cloud, Andromeda Galaxy, or all of these. So we definitely know you can see the Milky Way because we just spent a long time talking about the Milky Way and the legends of the Milky Way. Okay, looks like it's slowed down. 105 people voted, so I'll go ahead and end the poll. And before I share the results, let's look at the answer. There's 4 galaxies that you can see naked eye.
Wow.
And, we want to list them, but we'll let you guess one, Emily, that you can see naked eye.
The Large Magellanic Cloud.
Yeah, LMC and SMC, of course.
Small Magellanic Cloud. And then Jasmina.
The Milky Way.
The Milky Way. That's 3. And the 4th, Raja is an expert on the 4th.
That's
right. Andromeda.
The center of Andromeda is the furthest you can see with your naked eye. 2.5 million light years.
Next, now we go back to teacher Saeed and her student who are going to share some sky knowledge about the moon.
moon guidance. There are 28 station days in which the moon alignments along with the stars. These positions are associated with the weather. Somali people use moon and stars as a guidance for the weather. Those moon alignments fall in certain time and prediction weather. This is also used as a sign of a good or a bad will to the ones born under it. In the book of a God, he calls them station, and each statement falls on a certain prediction of weather. And the faith of the child will bring child born then. Those alignments, the meaning and names are taken from oral tradition. In addition, however, to the 28 stations, along with the visible path of the moon during each lunar month, they are said by Somali to be 1 or 2 nights, stars, and seasons and weather in Somali patriarchal tradition in every month during which the moon is not visible. Station 2. The moon in this station is held to be cast heavily rain and abundance of milky from the star. It also said to cast bright sunshine immediately following the rain, which dries up both land and milk. However, to the 8th and to the good rain begins with the least is said to be good because even the dryness caused by the really hot weather is healthy dryness and good for the stock. The men and women born under the nights of a list, they are said to have an extremely strong sexual appetite, a trait which can only be monetized by encouraging the individuals to become very religious. This is wax sentence. Station 15. If the gray suddenly rain begin with this station, then they will not be station 15. If the dry secondary rain begin with this station, then they will not be good for the needs of both people and animals. The clans will then have to travel visit distance in search of a better grace, and the burning camel will continuously lay with the family position. 5 to 6 stars in Virgo associated with this moon placement considered to be the station of war and finding warriors.
Thank you. Now we'll go to Dr. Osuji's class, who's going to tell us about some of the physical properties of the moon and the chemical properties of the moon.
The moon orbits around Earth and is Earth's only natural satellite. It has different phases depending on what side it's on. It takes 27.3 days for the moon to travel all the way around the Earth and complete its orbit. When it is night, the moon reflects light from the sun, making it bright at night.
The moon's center is approximately 480 kilometers in diameter, or approximately 2,000 miles.
The moon's composition. The moon is made up of layers: the lunar core, the mantle, and the crust. The lunar core is a solid iron-rich core. This is then surrounded by some magma and then a thick mantle, which is 1,300 kilometers deep and made out of various materials. This is then surrounded by the 50-kilometer crust, mainly made out of stuff like silicon, oxygen, and magnesium, etc.
During the Apollo 17 expedition, Harrison Smith used a tool to collect soil and rock, which showed that dried magma, was on the moon's surface. He also showed that the moon and Earth's composition do have similar traits, but they differ because of Earth's protective atmosphere and the moon's lack of.
Does the moon have water? Yes, the moon does have water.
It was confirmed by NASA that there are ice poles on each opposite ends of the moon. The M3 mapper was able to collect data from the dark craters, which showed the way light reflects and the way that the molecules are absorbed by these so-called ice blocks, and they do match.
NASA's SOFIA, or Stratospheric Observatory for Infrared Astronomy, confirms the detection of water molecules in the crater. Based on remote observations, the lunar poles have over 600 billion kilograms of water ice. This number happens to be on the low end estimate due to the fact that the water detected is limited by the strength of the spacecraft's radar.
How much water is found on the moon? There's 600 billion kilograms on the moon.
How is NASA exploring the moon? What challenges will they face?
It wasn't until the Apollo 11 crew in 1969 did the first humans land on the moon. Missions for moon samples exclusively only started in 1970.
The LRO, the Lunar Reconnaissance Orbiter, is trying to make a 3D map of the moon. This weighs 4,000 pounds and was launched June 18th of 2009. Basically, making a 3D map of the moon would just make it a lot easier to plan future missions with stuff like resources and just clean landing areas.
Moon water could help astronauts explore the moon for longer or even stay there.
Thank you to those wonderful high school students. Next, I wanted to show a map of Africa. Can we get that up? Maybe we can, yes. So what we wanted to show, you now know that Africa is not a country. It's over 50 countries, but you may not know that it lies in both the northern hemisphere and the southern hemisphere. And that white line is the equator as it runs through Africa. So you can see a substantial amount of Africa is in both the northern hemisphere and southern hemisphere. Great. So now let's look at the phases of the moon. So this is what the phases of the moon look like from the northern hemisphere. You can ask the question, why is the moon mostly female or a goddess in a lot of cultures? And as you watch the bright pattern of the moon, you can see how it gets big and small. And people associated that getting big and small with becoming pregnant, starting skinny, becoming pregnant, having a child, and then getting skinny again, and doing that over and over again. But it's also true that women have used the moon to keep track of their fertility when they have their periods. They can correlate it to a certain phase of the moon and know when they're fertile and when they're not. So there's several moon gods in Africa, and I wanted to talk about two more moon goddesses. One is Tanit from Carthage. Tanit was the patron goddess of Carthage in North Africa. Carthage is near where Tunis is now, in the country of Tunisia. So she was reigning over Carthage 2,000 years ago. The other moon goddess I want to talk about is Anu, with a click at the front. I'm not very good with my clicks, but it's Anu. And she is the moon goddess of the Sandawe people in East Africa in Tanzania. When the earth was made, Anu was the only celestial body in the sky, and everything was lush and cool and beautiful underneath the moonlight. But certain things happened, and then the sun came into the sky, and the sun was male and harsh and hot and scorching. So the Sandawe people remember that cool paradise where only the moon was in the sky. Even though lots of benefits came with the sun being in the sky, the sun is so hot in Tanzania that if you're not careful, it can kill you. In January of this year, the Space Launch System, which will be part of the Artemis program, had a test in Stennis Space Center in Mississippi. Let's have a look.
Okay, got your engine set. And we're in the cross count. Engine start. We're in the cross count. Call for south speed, continue monitor your system. And Brass is in control. All right, plus 25 seconds. DDRA, we did get an MCF on engine 4. Copy that, but we're still running. Still got 4 good engines, right? Got that. Advances through at 60 seconds. Get into our first gable profile.
DTD is
Gotcha.
do CCTC violation.
And we got a shutdown. Now personnel, shutdown. Let's all go to page 656. Page 656, please. And all personnel, it's going to be post-hot fire to shut down securing operations in page 656.
BTD, I need you to verify with the engine guy.
Yeah, sorry about that.
Down standby.
Yeah, all personnel, that does take us to the last page there on page 632. AR1, if you would, on step 4.241, please verify Procedure engine 1s and 4 have shut down for that step, and we have a safe engine shutdown.
We are post shutdown standby engines 1 through 4.
Right. So that was the January test, and they were supposed to test it again this week, but they then postponed that test because they found that a valve was stuck. So they're continuing to test the system, and they'll get it right. You know, NASA has a history of creating things, testing it until they get it right, and then off it will go. Now, looking at that video of that test of the rocket engine reminded me of African thunder gods. We didn't hear the sound because it would probably blow our ears out, but definitely looking at the exhaust and the fire reminded me of a forge and like a blacksmith. So we wanted to look at a few African thunder gods. We'll start with Teacher Saeed's class, and then go on to Dr. Osuji talking about these African thunder gods.
Naza, thunder god of the Gurage people of Utopia. The Gurage people are Habesha's peoples speaking the Gurage language inhabiting Utopia.
Dane, rain god also connected to the thunder of the Noor and Dinka people. The Noor people are a Nilotic ethnic group concentrated in the greater Upper Nile region of South Sudan. They also live in the Ethiopian region Gambela. The Dinka people are a Nilotic ethnic group native to South Sudan with a sizable diaspora population aboard.
Kibioso, lightning god, Iwi people, an ethnic group who occupy the southern eastern part of Ghana and also parts of neighboring Togo and Benin.
So, thunder god of Amlo, people of Ghana. The Amlo Iwi are a subgroup of the Iwi people of approximately 6 million people, southeastern parts of Volta region of Ghana.
Zivoso, god of thunder and lightning of the Fon people called Fonu, a geyser of Dahomey are a major African ethnic and linguistic group. They are the largest ethnic group in Benin, found particularly in the south region. They are also found in southwest Nigeria and Togo.
The Yoruba people are an ethnic group of over 40 million in total, inhabiting the south and north-central region of Nigeria, as well as southern and central Benin. Shango is one of the ancestral fathers of the Orishas of the Yoruba, Caribbean, and certain Latin American people. He is a highly revered god of thunder, lightning, and electricity, who is also the third Alafin of Oyo. Shango strikes through Ara, fire. His symbolism is a double-headed axe. The black and white photo is an image of Shango in front of the Nigerian powerhouse. Amadioha is the thunder god of the Igbos. The Igbo land is the home of Ndi Igbo. Ndi Igbo are a meta-ethnicity native to the present-day south-central and southeastern Nigeria. Large ethnic Igbo populations are also found in Cameroon, Gabon, and Equatorial Guinea, as well as outside Africa. Amadioha is foremost known as a god of justice. He speaks through thunder, and he strikes with lightning. He creates thunder and lightning by casting thunderstorms down to earth. He never manifests as a human, but often appears to humans as a white ram. Persons judged by Amadioha are either killed by Egbe Eligwe, lightning, Oko, fire, and or Miri, water, or attacked by a swarm of bees. Amadioha is also considered to be a creator god, Chukwu Okike. In some traditions, human beings were made by him when he sent a bolt of lightning down to strike a silk cotton tree, which split and revealed a man and a woman. The eye of Amadioha is Anyanwu, the sun. Ngai is the supreme god of the Kikuyu people. The Kikuyu are a Bantu ethnic group native to central Kenya. At a population of over 8 million as of 2019, they account for 17% of the total population of Kenya. making them the largest ethnic group in Kenya. Ngai does not manifest as a human being also, but is seen in the sun, moon, stars, comets, and meteors. Ngai also manifests as thunder and lightning during rain, or also as rainbows. Kiwanuka is a Lubale, god of thunder and lightning of the Baganda people. The Baganda people or the Ganda people are an ethnic group of the Bantu ethnic group native to Buganda, a sub-national kingdom in Uganda. Kiwanuka is also known as a god of justice. There is no physical representation of Kiwanuka, but Kiwanuka appears in the form of a Muganda warrior holding a spear in one hand and his hammer in another. He also wears a bangle. Kiwanuka has a wife. Her name is Nakayaga, the goddess. Both of them appear during thunderstorms as thunder and lightning.
Right, thank you for sharing those African thunder gods. So now's the real question. If we had the opportunity to rename the Space Launch System rocket, which African thunder god do you think we should name it after? So here's the poll. And we only are going to ask you about the names of the thunder gods that start with S. And there's 3 of them. One is So, of the Anlo people of Ghana. One is Sarah Watuka, which is the thunder god of the people of the Baganda people of Uganda. And the last is Shango, the thunder god of the Yoruba people of Nigeria. While that poll is going, we did ask Dawn Stanley, our NASA scientist, which of these 3 she would like to see as the nickname or the name of the Space Launch System. And it looks like most people are picking Shango, and she picked Shango as well. Dr. Sterling, did you want to share with us which name is your favorite?
Yes, actually it was, I didn't know how to pronounce it, so I thought it was much more interesting. Sasagosa, was it?
Which one?
The middle one?
Oh, Sarabwatuka.
Yeah, the double S. Because I would have loved to have seen folks try and pronounce it. But actually, I was thinking if it was more general, Ngai would be really good because it's so general. It includes comets and meteors in addition to the sun and the moon. So.
Thank you for that. Teacher Saeed, did you want to put in what your favorite name is?
Yeah, I would pick Shango because Shango is known through a lot of cultures, not just in Africa, but also in the Caribbeans and in also the North and South Americans. So
Shango, another one for Shango. Annette Lee, Dr. Annette Lee, did you want to give us your preference?
Annette here. I'll vote for Shango.
I'll vote for Shango. And Dr. Angela Osuji, did you want to tell us your favorite?
My favorite is Amadioha. But since we're going for S, I'll go for Shango.
And then teacher Vanegas, did you want to tell us? And I'll go ahead and end the poll.
Yes, I definitely think Shango. Because
Definitely
students from
Shango.
all over the world could relate to that. So
Yes. All right, so I'll go ahead and share the results. And Shango wins. So according to us, if we had the opportunity to rename the Space Launch System, we would call it Shango. Yay.
Thank you.
So, and it has to be said that Shango is popular in the United States as well because of the African slave trade, which brought people from the Yoruba culture to the historical south of the United States. So it's actually known. It's a African god's name that's pretty well known in the southern United States. So thank you for that. And that is the end of our program today, but we're going to stay on and answer a few questions. And I'll call Jasmina back so that she can answer some of the questions about her artwork.
Hey everybody, Annette here. I just wanted to say that while we're waiting for Jarita, we have put a lot of time into making resources, and these resources are on the Native Skywatchers webpage. So for example, there's a booklet and you can get all this information. There's a worksheet, the slides that go along with this presentation. A lot of hard work has gone into this. And the other thing I wanted to mention quickly before we dive into the Q&A is we do have 2 more events on this project officially, one in March and one in April. So the one in March is going to be focusing on Hawaiian Indigenous Astronomy, led by our friend and colleague Kalepa and his team. And the last one in April I'll be leading will be on bringing in art into this mix of astronomy, science, and culture. Back to you, Jarita.
And the first question is, why haven't people gone back to the moon or even sent unmanned probes or place a space station on it? Alphonse, do you want to take that question? Dr. Sterling?
Hello, yep, I'm here. Yeah, well, that's an interesting question. Well, I know I was trying to think of missions that have been to the moon since the Apollo era. I know for sure China has been, and I can't recall offhand others, but people have been back to the moon. Not people, but vehicles have been. Now, it's really an interesting question, and that about why the Apollo program, for example, ended. And that really ties in with a lot of things. It's not only the space and the science. In fact, that has maybe the least to do with it. It's politics and it's money, for one thing. You know, it cost a lot of money, and so people were wondering how to spend the money. So the space program, after we had reached the moon, kind of the incentive to get there, well, obviously that was gone, and so that removed some of the funding. Another thing is just the situation in the world then. There was a lot of competition in the world, and it was between like the US and the West and the ex-Soviet Union. And really, Apollo and the whole space program was largely built on a race to get to the moon. And it was a technological competition between the US and the Soviet Union. But again, it goes into history, but there were lots of changes in the world. And so the motivations from that standpoint just kind of evaporated. So that's one reason we didn't go back. I'll cut it there. It's a very involved question.
Go on. Go on.
Jarita, we have some questions for Jasmina and you. Would you like to take those?
Certainly.
Okay, so here's a question for you, Jasmina. How long did it take you to create the art? And this is from a teacher at South High School.
Okay, well, it took me about 1 day to create each works of art. And at first I had to sketch them, and then I drew them on my iPad with my finger. It's quite time consuming, yeah.
Okay, great. And now we have another follow-up question on that. Jasmina or Jarita, can you elaborate on some of the mythology of Liza and Mawu, the origin stories, connections to the sun and moon, etc.? Is there any comparison to Artemis and Apollo? So maybe that was earlier, but maybe you can just circle back around.
There's actually, as far as I know, there's not like an equivalent complicated myth that involves Orion the way that Artemis and Apollo are entwined with the Orion myth. They're twins, and one rules over the day and one rules over the night. And again, their duties change depending on which ethnic group you're talking about. So that's it in a nutshell. I'm sure there's more elaborate legends, but I don't remember them off the top of my head. So I was looking at Elizabeth Wallace's question. Hi, Elizabeth. And she asked if Canada is participating in Artemis, and the answer is yes. They're going to be participating in Artemis too. Right? And here's the next one from Elizabeth Wallace is, can you talk about the headpieces that you drew?
Oh, no. So the headpieces are, I got them from the Benin sculptures and the stone pieces, and I just copied some of the patterns and tried to make it look more 3D, which kind of didn't work, but it looks cool. Looks cool.
And then Luna asks, what's your favorite form of doing art?
By hand. I like
just
sketching.
Yeah. In fact, here in my office, I have 2 of her sketches hanging on the wall.
Oh, proud mom.
Yeah, I'm looking here. We've got a question from one of our Ojibwe elders. Let's see, maybe he'll be able to jump on the call and talk. Will, are you there?
I am.
Bonjour, Anin.
Anin, bonjour. I was really pleased by first the opening prayer at the very beginning in that acknowledgement that was identified in some of the description. Part of it spoke to the bearing of placenta. And I thought that was very powerful because you could see that throughout many tribes in the Americas before contact, and how that seems to be a really strong relational connection to that blood relationship to the earth itself. And so that was powerful. But when many of the other elements were spoken about, like the moon cycle, as well as the connection there, was strongly connected to our association to the moon, as well as to the patterns on a turtle's back. On their shell, and then the thunder gods that were there. The Anishinaabe, the tribe that my ancestors are from, is represented by the thunder bird, and Nimki B'nai Shi is its name, and we understand that relationship. They are our ancestors, and where our Anishinaabe ancestors come from are the stars. And so I just felt it was very powerful that there is a global connection between indigenous tribes, that there is a relationship with the stars.
Oh, Miigwech Pilamia. That's really well said.
Well said.
Yeah, and in Dakota, Lakota, we have Chekpa, which is our umbilical cord and our star twin as well. So it's really beautiful and empowering for me to see this connection with, like Miss Osuji was saying, Dr. Osuji, about the traditions they have with the umbilical cord. And I know the Hawaiians have similar traditions too. Maybe Kalepa will be talking about that next week.
Dr. Osuji, did you want to say something?
Thank you so much for mentioning that. I felt that that was something that we needed to put out there. And we always believe, Native Igbos, that we are all connected. We're all relatives. And
we have a very strong connection to the land. We also have a very strong connection to the stars. So as we look at them, we have this systems approach to how we connect with ourselves, materials, and things around us that are also not material. And I am also very moved that also it has this connection to the indigenous people of the land that I am now a part of, the land of my sojourn. Thank you.
So we're at the top of the hour now, so I think it's time for us to say our goodbyes. So thank you so much for joining us today, and thank you for your input and participation in our polls. And let's hope that NASA hears us and renames the Space Launch System or gives it the nickname of Shango.
And thank you for the Shango vote. I am highly honored.
Yes, Dr. Osuji is from Nigeria, so to have a Nigerian, but also diaspora African thunder god is really a privilege. So I'll go around with each of our panelists to allow them to say goodbye. Teacher Said.
Thank you so much for giving us this opportunity and your time. We appreciate you showing up and listening with all your attention. We appreciate you taking the time to be here and be present with us. Thank you very much.
And I have to say that thank you so much to your students, to all three of our teachers. Your students were great. And they were mostly shy. They didn't want to show themselves, but we did get to hear their voices. So Teacher Vanegas.
Yes, thanks everyone for coming and connecting with us today. And our students have really appreciated this opportunity to learn and to share what they learned with you.
Okay. Thank you. And Dr. Osuji.
Thank you so much for this opportunity. My students at Washburn High School are very grateful, and especially for you, Jarita, coming to see them and critique their work. They were beyond happy. And I sincerely hope we would have had an opportunity for all of their projects to be shown. But thank you all the same. They are actually here on the Zoom with me as well. Thank you. Thank you, Annette. Thank you, everyone, for putting this together. And especially on this month of February, I am very grateful.
Thank you. Dr. Sterling.
Okay, thank you. It was really great. I really enjoyed it. And I was happy to see so many participants from so many parts of the world. And I think that one of the most important things to keep in mind is that whether it's Artemis or Shango or whatever, remember, you can be on it. You have to work hard and study and make sure that you stay on top of gaining knowledge and expanding your knowledge and working as hard as you can. And you can be on these missions. You can go to the moon. You can go to Mars. And we are looking for you to do that. So let's get with it. Thank you.
That's great. So we'll say goodbye from me and Jasmina, and we'll turn it over to Annette. Thank you again for attending, everyone.
Thanks, Jarita. Yeah, so the last thing I just want to say that to circle back, we had this great gathering, this Zoom gathering around the Zoom fire, and we had this voice. It really means a lot. I hear in my heart the voice of all of our team and especially the students. I just want to say, like, this is really meaningful. This is Native Skywatchers, our vision to be able to have an Indigenous-led event. Our Indigenous voice is leading this. We're producers. We're producing this. And why are we doing it? Because we have value added to just that single story of the Western science. And so let's really practice that, widening the lens and letting everyone come to the table, all cultures, all peoples. And I guess I just want to say in closing that this is a really hard time. We're getting our butts kicked by COVID. And, you know, I'm feeling it. You're feeling it. We're all feeling it. But what I want to say, you know, it's a painful lesson. We share one air. That's the lesson, right? We share one air. How simple. Okay. But the thing of it is that let's not give up. Let's not give up hope. We are getting our butts kicked. We are having a hard time, but we are rising to the occasion, and we're producing, we're creating, we're finding our truth, our voice to make something meaningful in the worst of times. So this is just a baby step. This is the beginning. Let's keep this fire going. Pilamia, mitakiasen.